In this video, I'll be talking about the notes from section 10.2 day 1. This will be our first video over arithmetic sequences. This is a special type of sequence in which the difference, so when you subtract them, in which the difference between successive terms is a constant number. And we call this an arithmetic or an arithmetic sequence. Now the constant that is found every time you subtract them is called the common difference, and we're going to denote that with the letter D. So this is kind of the defining trait of these sequences. Whenever you subtract successive terms, you get the same difference over and over again. So in example 1 and 2, we're going to find that common difference and then find some specified terms of the arithmetic sequence. So for problem number 1, they give us 17, 12, and 7. So the best way to find the common difference is to take, for example, the second term and then just subtract it the first term. So that would be 12 minus 17, which is negative 5. And you can find that same difference by taking maybe the third term and subtracting the second term. So it should be the same because that's the definition. It's the common difference. So the third term is 7, and 7 minus 12 is also negative 5. So that negative 5 is definitely the common difference. And if I were to keep that pattern going for the next 4 terms, 7 minus 5 would be 2. 2 minus 5 would be negative 3. Minus 5 again would be negative 8. And subtract 5 again is negative 13. So the big thing to watch out for when you're finding the common difference, don't take the first term minus the second term. Take the second term first and then subtract that first term. So in problem number 2, it says find the first 4 terms and then tell me what the common difference is. So let's start by finding the first few terms here. All right, so for the first term, I'll plug in a 1, and that would be 8. If I plug in a 2, that would be 11, and then it would be 14, and then 17. So now that I have the first 4 terms, I can find the difference. You can either do 11 minus 8, you can do 14 minus 11, you can do 17 minus 14, but all of those should come out to be a difference of 3. So 3 is going to be that common difference. All right, so the nice part is because an arithmetic sequence always talks about this common difference, there's a formula that we can use for any of these arithmetic sequences. So it looks like this. A sub n is equal to a sub 1 plus n minus 1 times the difference. And just to remind you, a sub 1 is the first term of the sequence, and d is the common difference. And n is the same n that we've seen previously. It's just talking about if this is the 100th term, then I put in 100. So the n is the value of the term you're looking at. So we will eventually get an answer that'll look like this. And if you go back to problem number 2 here, the common difference is 3. That 3 is actually the multiplier on the end. It's not being subtracted or added. It's a coefficient on the variables. So just kind of be aware. Some people, when they see common difference, they think, oh, it should be something minus 3. And that would be for a recursive sequence. But in explicit formula, it shows up a little bit different. So let's go down to the examples. It says for number 3, find the 13th term. So I'm going to find a sub 13. I'm going to take the first term, which is 2, plus, now n minus 1, so if I'm finding the 13th term, that would be 12. And then you need to find the common difference. So what are they doing every time? So here they're adding 4. So I'm going to put in a 4 for this problem. So this would be 2 plus 48. And so the 13th term would be 50. There it is. Number 4, the 68th term. So a sub 68 would be the first term, 25, plus. Now n minus 1 would be 67, and then you need the common difference. And here the common difference is going to be negative because they're subtracting. 17 minus 25 should be negative 8. So in this particular one, it would be 25 plus negative 536, which would give you negative 511 for the 68th term. So when the common difference is negative, that just means they're subtracting. When the common difference is positive, that actually means they're adding. All right. And the last one actually wants you to work backwards. It says find the first term, given that the 25th term is 139, and the difference is 3/4. So they're adding a fraction every time. So I know that the 25th term is equal to the first term plus, all right, so if this is the 25th term, then this would be a 24 times the common difference. But the one other thing that I need to plug in is this 139. I waited to plug it in just because I didn't want to throw too much into the problem at once, but the 139 goes out front. It's the 25th term. But having that a sub 25 here reminds you why this is 24. So I'm going to replace that. But at the same time, I could take 24 times 3/4. I believe that's 18. And then I can, subtract 18 over? So I should get 121 as that first term. So I actually prefer section 10.2 and 10.3 more so than 10.1 because 10.2 is all about arithmetic sequences, so we can use this formula up here over and over and over again. Let's go to the back. The back is just going to help us just a little bit more with that formula. It says find an explicit and a recursive formula for the nth term. So here, instead of finding the 68th term, we're going to find the nth term. So just recall, we're going to need this. And this is specifically for explicit. So I'll come back to recursive here in a moment. But I don't know the nth term, but I do know the first term. And because I don't know the nth term, I have to leave this as n minus 1, which is fine. And then I'm going to plug in the common difference. It looks like they're adding 9 every time. So I'm going to put a 9 here. But to clean this up, I'm going to distribute. So this would be 12 plus 9n minus 9. So then the formula would be 9n plus 3. And so this is something where if I wanted to know the 100th term now, I could take 9 times 100 and add 3 to it. But notice the common difference is 9, and that 9 shows up as a coefficient on the n value. So if you wanted to write the nth term explicitly, it's this step right here. But if you wanted to do recursive, okay, the recursive, you have to know the first term, and then the next term is found by taking the previous term, and what are they doing every time? They're just adding 9. So here you don't have to solve for anything. You just have to write it out with the first term and what happens to the next term in the sequence. So I'm actually going to just kind of stop with recursive for the back page and focus more on explicit. So for problem 37, I know the first term is 35, and then the common difference, it looks like they're subtracting 12. So I'm going to put a negative 12 here and then use distribution. So this would be 35 minus 12n plus 12. So then the formula would be negative 12n plus 47. And that's it. So you don't have to go any further because they told you to find the nth term. And the last one here, a little bit different. Instead of giving you the first 3 or 4 terms, they're just giving you 2 terms, none of which is the first term. So we know that the 8th term is 75 and the 20th term is 39. You've done problems similar to this, but not in relation to sequences. Think about finding the slope between 2 points. right? So we know that, if I wanted to find the slope between 2 points, I could take y minus y over x minus x. And so if I take 75 minus 39, I get 36. And if I take 8 minus 20, I get negative 12. And that gives me negative 3. And this negative 3, I'm going to tell you right now, it's not slope per se, but if you think about slope as a definition, it's the constant rate of change. So in a sequence, or in arithmetic sequences, the constant rate of change would be the common difference. So if you find the slope in an arithmetic sequence, it gives you the common difference, because the common difference is what's constant about these sequences, just like a slope. So now that I have the common difference, well, it might not be so hard to go back and find the first term, because I need the first term to write out the formula. So you'll have to pick one of these points. It doesn't matter which one. But over here, and I'm just going to use a sub 8. A sub 8 is equal to the first term plus, now n minus 1 here would be a 7, and then the difference we know is negative 3. But the other part is I actually know what a sub 8 is equal to. It's 75. And then if I add the 21 back over, I think I get, 96. So the common difference is negative 3, and the first term is 96. So then if I start to plug in that information now, the formula would be negative 3n plus 99. So given 2 points of or 2 terms of an arithmetic sequence, you could treat it as 2 ordered pairs and find the slope between those ordered pairs, which would be that common difference, and then pick just one of those terms and go ahead and solve for a sub 1. Those are your notes for today.